Okay, hey, we are going to pick up where we left off on our video where we started introducing how these waves could have horizontal shifts or horizontal stretches to them. So your homework assignment tonight is going to be to do the problems you did not do on the worksheet from yesterday. And so 3, 4, 5, 8, and 9. And these are all going to be problems that are going to be dealing with radians instead of degrees. Okay, so the two main things that we learned yesterday was that the term phase shift really is just, hey, where does my wave start now? Because it might not start right there at 0. And then the term period length, once again, please keep in mind, this is not where your wave ends, but rather it's how long your wave spans. And so to answer the question for period length, you have to take where the wave ends minus where it begins, and that gives you that distance or that period length. Okay, so we're just going to look at two problems today, just using the same notes page from yesterday. The reason I know that this next problem is definitely a radian problem is because as you examine what is in the parentheses, you will notice that you see a pi symbol there. Okay, that is telling me that this is in radians versus a problem, and I will tell you that there should have been a degree symbol on this problem from yesterday for number 3, but if you do not see a pi symbol, you can assume that the problem is wanting you to label the x-axis in degrees. Okay, so let's go ahead and see if we can answer the questions, the first 3 questions, which are generally pretty easy, don't require any calculations. For this problem, the midline would be at 1. That's the +1 at the end. The amplitude is what we're multiplying in front by. That's the 5. Again, the amplitude is always positive. And then the flipped is a yes or no question based on whether the number multiplied in front of your trig function is negative or not. And in this case, there would be no flip because that number in front of sign is a positive 5. Okay, so there I was able to answer those questions. Technically, I could at least put my midline in place here at 1, and I have a really huge amplitude on this, so I'm going to need to maybe do a little bit of extending here of my y-axis. I need to make sure that I have enough space and that it's labeled that I can stretch 5 more units above this midline and that I have labeled 5 more units below the midline. So I'm going to go ahead and do that right now, labeling all the way up to 6. And if you think about this, if I'm at 1 right here for my midline and I need to stretch down 5 units, 1 unit would be down to 0, then down to -1, down to -2. I think that I need to go down to -4. So I have enough space to stretch down 5 units, again, from the midline. Okay. Now, you cannot place your points yet on the midline, even though we know this is a sine wave, and we know the sine wave should cross that midline at the beginning and at the middle and at the end. Right now, we do not know where the beginning and the middle and the end of this particular wave is located at. Okay, and so what we need now is we need to figure out that phase shift. And again, keep in mind that is where your wave starts. And so what you will do is you will grab what is in the parentheses here. Okay, just that portion. Now, here's where you're going to do something a little different than we did yesterday. Okay, yesterday we put our inequality symbols on each side, which you'll still do that. But yesterday we were doing the problems in degrees. And so we put 0 degrees on the left and 360 degrees on the right, because that is where a parent function wave starts and stops in degrees. If it's a radian problem, then we would say, well, on the left, the parent wave would start at 0 radians, but on the right, if we're talking about radians, I don't want to put 360 degrees there. I want to put 2 pi radians, because that's what I would get if I converted 360 degrees into radians. This would end up simplifying to 2 pi. Okay, so that is a very crucial difference between today's problems and yesterday's problems. If it is a radian problem, it has to be wedged between 0 and 2 pi. Okay, now from here, we're going to do the same thing we did yesterday. We're just going to use algebra here to get the x in the middle by itself, but this is just going to feel, I don't know, a little bit more difficult because you are working with fractions. You do see the pi symbol in this. Let me encourage you to use your calculator, but don't enter the pi button on your calculator. Okay, so for example, I think that we all would agree that the first thing we'd want to remove from the middle is that negative pi over 6. So we're going to add pi over 6. We're going to do that to all 3 sections, just like we did yesterday. Of course, on the left side, this is easy. We're just adding pi over 6 to 0. So that's going to have the left side now be pi over 6. Now in the middle, I only have the 4x. But here's where you're going to want to use your calculator for combining 2 pi and pi over 6. Okay, what you're going to want to type onto the calculator is just the coefficients of these terms, so not the pi symbol. Okay, so think of this pi over 6 as being the fraction 1/6 that's in front of the pi symbol. Okay, so what you're going to type on the calculator is you're going to type 2 plus a 1/6, okay? Now, you're going to see a decimal. You need to use the math fraction button. You must switch it back into a fraction. So on your calculator screen, you're going to see the fraction 13/6, but then when we write this over here, you're going to reattach that pi symbol onto your answer. It's kind of like saying 2x plus a 1/6 x is how many x's? Oh, it's a 13/6. X. So that pi symbol is kind of treated like a variable x. You have to keep it there onto your answer, even though we're not typing it into the calculator. Otherwise, your answer on your screen is going to be stuck as a decimal. Okay, so let's keep getting this x in the middle by itself. I'm going to divide the middle by 4. But let me encourage you, instead of dividing each of the ends by 4, since there are already fractions in those locations, instead of dividing by 4, let's do something similar, which would be to multiply by the reciprocal of 4. We're going to multiply by 1/4. Okay, that's going to make my fraction on the left be 1 pi over 24. The x is now by itself in the middle. And on the right, I have 13 pi over 24. Okay. Now remember, the value all the way on the left, once the x is isolated in the middle of your inequality by itself, this represents what we call your phase shift. And that is telling you where the wave begins. Okay, this is very important because this is the start of you now actually being able to label the x-axis. Okay, so I'm going to fill on our blank up here that we know that this wave starts at pi over 24. Okay, don't be scared if these fractions end up being weird numbers. Like, even this 13 pi over 24 kind of feels weird. That represents where the wave ends. Okay, it's not something we write down on these blanks up here. Okay, please keep in mind this number for where the wave ends is not your period length. Okay, but I'm going to take where the wave begins and where the wave ends, and I'm going to go ahead and put that onto our graph. Okay, so I'm going to put a little marking here and label that it's starting at pi over 24 radians. I'm just going to put a mark all the way over here on the right side that it's ending at 3 pi over 24. And then we're going to use the same strategy we used yesterday for how to locate the middle of the wave. Okay, remember what we did yesterday when it was in degrees. We averaged together where the wave started with where the wave ended. And so again, all this is just going to be done on your calculator. Okay, again, do not type the pi symbols in, but what you will type on your calculator is you will type the fraction 1/24 plus 13/24. Okay, and I would encourage you that when you type that in to definitely hit enter after you've done that. Okay, and then you're going to hit enter, and then you're just going to simply make sure you divide that sum, though, by 2, because you are averaging these. If you just add them up, you're not finding the middle. You have to then divide by 2. Okay, so on the calculator screen, I'm just writing this down just to show you. You do not need to write these calculations down. I'm seeing the fraction 7/24. I would need to, on my picture, attach the pi symbol and say 7 pi over 24. Okay, so without me writing down the rest of these calculations, what you would do to get the 1/4 mark is you would type in 1/24 plus 7/24, divide that answer by 2, and then switch that answer back into a fraction. You should see on your calculator the fraction 1/6. Okay, notice though, when I added it to my graph, you have to put the pi symbol on it. So it's really pi over 6. Okay, doing the same thing for this. I would average 7/24 with 13/24. You add those together, you divide by 2, you switch it back into a fraction, you see the fraction 5/12, but you do need to attach the pi symbol there. Okay, a little bit more work, but all of it really just done on the calculator. Okay, once you have, and you have to have those 5 labels on your graph there. Now we can look back and say, okay, what kind of wave are we sketching here? We are sketching a sine wave, and so we've learned that the sine wave is supposed to cross that midline at the beginning, at the middle, and at the end of the period. So you want to put dots at pi over 24, 7 pi over 24, and 13 pi over 24. Okay, now this one we said no, that this sine wave is not flipped. Okay, remember, if you look back at your notes page, the sine wave normally starts up as a hill and goes down as a valley. And so I'm going to keep going in that same direction. At the 1/4 mark, which would be right where this pi over 6 is, I'm going to travel up because this is not flipped. But look how much I'm going to go. I'm going to go up 5 units. So that's going to land me all the way up at 6. And then at the 3/4 mark, which is technically right above where the 5 pi over 12 is, now I'm going to stretch down 5 units. I'm stretching the amplitude. That puts me at -4. And then I simply connect those dots together to get my graph. Okay, don't forget, you do need to fill in the blank for the period length. Okay, this is how long is this wave spanning. Okay, we get that by taking where your wave ends, that's 3 pi over 24, minus where the wave begins. Okay, this is not an average, this is just a subtraction. So on the calculator, you would type in 13/24 minus 1/24, switch that back into a fraction, I'm seeing 1/2 there, and just attach the pi symbol onto the 1/2, it'd be pi over 2. Okay. Okay, we're going to try one last one quickly here. Okay, the midline is at -1. The amplitude is 2. We're saying no to the flip. I'm going to go ahead and place my midline there. Make sure I can stretch up 2 units above the midline and down 2 units below the midline. Okay, I can clearly see this is a radian problem because I see the pi over 2. So when I place what's in the parentheses in my inequality, I'm going not from 0 to 360, but 0 to 2 pi. Okay, now I'm going to pick up my calculator because I'm going to need to use it when I'm kind of working this out here. Okay, I'm going to get rid of that pi over 2 from the middle, so I'm going to add that to all 3 sections, but when I get to this last section, here's where I'm going to need my calculator. Okay, I'm going to type in 2 plus 1/2 on my calculator. Okay, I'm going to switch that back into a fraction. I see 5/2, but I do need to attach the pi symbol. Okay, next, I want to get rid of the 1/4. Well, instead of dividing by 4, since this is littered with fractions, I'm going to multiply by the reciprocal of 1/4, 4. Okay, it's going to make this so much easier. Okay, now the x is by itself in the middle. I'm seeing I have 4 pi over 2, and over here I have 20 pi over 2. I'm going to reduce those values. Whoops, I'm going to reduce those so that this reduces to 2 pi, and this reduces to 10 pi. The 2 pi is my phase shift. I'm going to go ahead and fill in period length. Remember, that's where the wave ends minus where the wave begins. The period length is 8 pi. Okay, be very careful though. This 10 pi needs to be where I'm marking that the wave ends. So starting at 2 pi, ending at 10 pi, I'm going to average those to get the middle. 2 plus 10 is 12. 12 divided by 2, I get 6 pi in the middle. I'm going to average these, I get 4 pi, and I'm going to average these, I get 8 pi. Okay, now I'm ready to place my points. I'm going to look, what wave are we sketching? Oh, we're doing the cosine wave. So I need to put a point at the 1/4 and the 3/4 mark. I am not flipping this. So at the beginning, and make sure you're very careful, the beginning is not right here at 0. The beginning is right at 2 pi. You would want to count up 2 units from your midline there, in the middle down 2, and at the end back up 2 to get that cosine wave. Okay. Always happy to answer any questions. We can set up a quick individual Google Meet if any of you need to do that. That way we can kind of have a conversation back and forth if you need to. But please note that you are just finishing the remaining problems on the worksheet that are all radian problems.